This presentation focuses on analyzing the coronavirus data for the year 2020 and 2021 using SQL. The presentation structure includes a problem statement, dataset overview, dataset explanation, and data exploration using SQL. Coronavirus first known case was identified in Wuhan, China in December 2019. The disease quickly spread worldwide, resulting in the COVID-19 pandemic. The coronavirus pandemic has had a significant impact on public health globally. So this analysis uses SQL to identify the patterns and impact on this coronavirus. The dataset includes information on provinces, countries and regions, latitude, longitude, data, confirmed cases, deaths and the recoveries. When it comes to dataset explanation, the key terms in the dataset are provided as below. Let's go to the data exploration using SQL. SQL is used to explore and analyze the coronavirus data here, and this SQL plays a vital role in deriving valuable insights from the dataset for better understanding of the virus spread. First of all, this first query is to check the null values. First query represents a straightforward method of checking for null values, listing all the columns and checking each for null separately. And the second query employs conditional aggregation to count the number of null values in each specified column, resulting in a single value for each column specified here. Here, this part is used to check the updating the null values with 0. So it specifically updates each column, and also it effectively fills in any missing values with zeros, ensuring that all the columns have a value, and it prevents potential issues in calculating or analysis due to the nulls. Here, to check the total number of rows, SQL query retrieves the total number of rows in the data set by counting all the rows. And here, to check the start date and end date, this function calculates the dates, minimum and maximum dates from the data column in the data set, and then it converts to the data format, and after that it returns a start date and end date from the data set. And here the number of months in the data set, as we discussed, this function calculates the number of distinct values in the specific expression using that each unique combination is counted only once, and this extract the year and months from the converted date, and also it assigns to the results of the function. So when we execute this query, it will return a single row with a single column label how many number of months, so containing the number of distinct months covered in the data set. And here to check the monthly average for confirmed deaths and recovered, this query provides insights into the average values of confirmed cases, deaths and recoveries per month for the year 2020 and 2021, facilitating analysis of the progression of the COVID-19 pandemic over time. This one, we had to check the minimum and maximum values per year. So here what we do is this expression extract the year part from the converted date values in the date column, and then it calculates the minimum and maximum values for the confirmed deaths and recovered cases for each year. Here total number of cases in each month. This function extracts the year and month from the converted date values in the date column, and then it calculates the total number of confirmed deaths and recovered cases for each month and year. So here the group by clause is group the data by year and month extracted from the date column, and the order by clause sorts the results set in ascending order based on specific columns. Here we have to check the virus spread with respect to confirmed cases. This function counts the total number of confirmed cases present in the dataset. The main query calculates statistical measures, and then based on the data from the main dataset, it calculates the average from sub-query query. In this one, the main query calculates the statistical measures based on the data from the main dataset, and then calculates the average from the sub-query query. So that's how we show the virus spread with respect to recovered cases. Here we have to check the country with the highest number of cases. So what happens here is this clause selects only the first row from the resource set, which will be the country with the highest number of confirmed cases. So this calculates the total number of confirmed cases for each country, and then it filters the rows and apply the conditions, and after that it sorts the result set in descending order based on the total confirmed cases. So based on their total confirmed cases in descending order, this ensures that the country with the highest number of cases appears first. Here, country with the lowest number of death cases. What happens here is that the clause selects only the first row from the resource set, which will be the country having the lowest number of death cases. So here they calculate the total number of each case for each country, and it filters the rows and apply the conditions, and after that it sorts the result set in the ascending order based on the total death cases. So based on their total cases in ascending order, it ensures the country with the lowest number of cases appears first. Here we have to check the top 5 countries having the highest recovered cases. So here it calculates the total number of recovered cases for each country, then sum up these values for each country. After that it applies the conditions, then sum up these values for each country. After that it sorts the countries based on the total recovered cases in ascending order, ensuring that the countries with the highest case appears first. The key insights revealed by this SQL analysis is it shows where cases, deaths and recovered cases occur, aiding in understanding the virus geographic impact and identify trends over time, spotting spikes and declines in cases, and evaluating recovery rates, and revealing how well treatments and healthcare systems are working, and pinpoint host of high case concentration, guiding targeted interventions, and break down cases, deaths and recoveries by demographics, showing who's most affected. And the significance of using SQL to analyze this coronavirus data in this analysis is SQL allows easy retrieval, aggregation, filtering and transformation of data, and it's scalable for large data sets like coronavirus data. And with SQL analysis, it's reproducible and flexible, enabling exploration and insight generation. Thank you.